Okay, here are the formulas we're going to be using to solve this problem. The formula for the nth term of an arithmetic sequence is a sub n equals a sub 1, the first term, plus n minus 1 differences. And for this sum of an arithmetic series, the nth sum is the number of terms times the average of the first and the last. So way to think about it. Now, if they tell you that a sub 4 equals 12, that's the same as the additional information that gives you is that n equals 4, because and that the fourth term is 12. So if we substitute into this formula, a sub 4 is 12 equals the first term, which we don't know, plus, since n is 4, 4 minus 1 is 3 differences. So we have one equation right now with two unknowns, a sub 1 and d. But we can use the second piece of information, that a sub 16 equals 42, which tells us that n equals 16, to find a second equation. Again, substituting into this formula for the nth term, 42 equals a sub 1 plus 15 differences. 16 minus 1 is 15. So here's a system of two equations and two unknowns. I can subtract this bottom equation from the top equation, which will eliminate the a sub 1. So 30 equals 12d. Divide by both sides by 12 and reduce, and you get the difference is 5/2. And now that you know what d is, you can substitute into either of these equations to find a sub 1. I chose to substitute 5/2 in here, and a sub 1 equals this 12, take away 15/2, or 9/2. And here I copied down the first four terms in that sequence just to see as a sanity check. 9/2 is the first term. Add 5/2 to get to the next term. 5/2, 5/2, and this fourth term looks like it's 12. And that makes sense. So we're ready to find a sub n. A sub n is equal to the first term plus n minus 1 differences, but the differences are 5/2. And then I can distribute the 5/2 and simplify, and there's a formula for a sub n right there. And I can use that formula to find the 20th term. Just put 20 in for n. 2 into 20 is 10. 10 times 5 is 50. 50 plus 2 is 52. So there's your answer for a sub 20. And the sum of the first 20 terms is the number of terms times the average of the first and the last. That is a sub 1 plus a sub n. And if you could divide this 2 into 20 and get 10. Add 52 plus 9/2, and you get 56.5 times 10 is 565. Okay, so there is your answer for the sum of the first 20 terms. And there's a picture that corroborates everything we just said. I used the Desmos summation notation against this formula for the nth term. I'm adding together x of these terms from n equals 1 to, in this case, 20, and there's the 565. And here, g of x, I represent the a sub n, and found g of 20, g of 4, g of 16. They all match everything we expected. So there you go. Hope that helped. If you have any questions, post a comment.